Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is two-pile game. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. Alice and Bob are having a tea party. Of course, there must be snacks at the party. Laid out on the table in front of Alice and Bob are biscuits and cakes. Initially, there are X biscuits and Y cakes. The two takes turn eating snacks. Alice goes first. On their turn, a person can do exactly one of the following three things. First is eat one biscuit that will reduce the value of x by 1 and will not bother y. The second thing that they can do is eat one biscuit and eat one cake that will reduce both x and y by 1. The last thing that they can do is eat one cake and then add one more biscuit to the table. This will reduce y by 1 and increase x by 1. Now, the number of cakes and biscuit on the table must remain non-negative at any point of time. So, it's not allowed to eat a biscuit if there are no remaining biscuits. So, for example, a person who eats the last snack will be satisfied. So, both Alice and Bob will choose their moves optimally in an attempt to be satisfied. With the given initial values of x and y, we need to decide who will be satisfied in the end. Let's see the input format. We have t test cases, and for each test case on a single line we will have two integers x and y, the number of biscuits and cakes respectively. For the output, we simply have to output Alice or Bob depending on who will be satisfied under the optimum snack eating choices. As for the constraints, number of test cases will go from 1 to 10 raised to 4, value of x and y will go from 0 to 10 raised to 9, and the sum of x and y will always be greater than equal to 1. Let's see some sample inputs. So for the first sample input, the value of x and value of y are 2 and 0. So there are a total of 2 biscuits. The first biscuit, because Alice is playing first, will be eaten by Alice, right? And the second biscuit will be eaten by Bob. So the person who is satisfied is Bob. Therefore, the answer is Bob. Similarly, for the second sample input, there are 3 biscuits. Since Alice will eat the third biscuit, right? Now Alice will be the last person to eat the snack, therefore Alice will be satisfied. For the third sample input, we have 0 biscuits and 1 cake. So the only operation that Alice can perform is eat one cake. But if you remember, if we eat the cake only, we have to add one more biscuit. So now one biscuit will be added, and that biscuit will be finished by Bob. Therefore, Bob becomes the last person to eat the snacks. Therefore, Bob is satisfied. Let's see how we can approach the solution. So we know that the operation that we can do is we can either eat a biscuit, we can eat a biscuit and a cake, but if we decide to eat a cake, the count of cake will decrease, but the count of biscuit will increase. So can we put it in like that, that one cake is equal to two biscuit? If we do all the second operations first, that we reduce the biscuit and cake as much as we can, and then we will either be left with biscuits or cakes. If we are only left with biscuit, the only operation that we can do is eat biscuits. But if we only have cake, it means that each cake gives us two operations. So first you will eat the cake, and then this cake will end up adding one more biscuit. So we have to now finish this biscuit as well. So what we can do is, we have x with us and we have y with us. What we can do is, we can simply make x plus 2 times y. So we are considering each cake to be as twice of biscuit. Now since Alice always plays at odd and Bob will always eat at even, so if the final x after doing this operation, if x is odd, then Alice will be the last person to eat the snack, and therefore Alice will win or Alice will be satisfied. If x is even, then it will be Bob to eat the last snack and Bob will be satisfied. And with this, we get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, and solve will take the input of x and y. As we have seen in the approach, we consider each cake as two biscuits. Therefore, we add up twice of y to x. Now, since Alice plays at odd points and Bob plays at even points, if the parity of x is odd, then Alice will be the last person to eat the snack and therefore Alice will be satisfied. Otherwise, Bob would be the last person and we print Bob. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of x and y, add 2 times y to x. Now if x is odd, Alice will win. If it is even, Bob will win. We print that, and as you can see, I have AC in Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.